And here we have the lane guidance camera. Doesn't this look funky? Oh man, that's got spaceship written, like shuttlecraft written all over it. Does a shuttlecraft make that noise? I don't think so. Put, 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 put. No, it's like silent because it's in space. Pigs in space. And I don't know anything about lane guidance cameras because I don't have a car fancy enough to have such a thing. But there we go. There's the connector interface. Couple of screws on the back. Should be really simple to open. And there's our camera. So I'm not sure how much processing hardware is going to be inside this thing. I mean, it's a die-cast alloy case. So, another Teardown Tuesday item? Or should we open this now? Alright, what the hell, let's do a full teardown of this thing right here and now, shall we? Let's not wait for Teardown Tuesday. This will probably be it for the mailbag, by the way. Depends on how much is in here. I expect quite a lot of real-time processing power for this lane guidance, lane vision camera. I think they do a lot more than that, just for, you know, they do a hell of a lot more. They you know, object detection and all sorts of whiz-bang stuff. I don't know what Hyundai car it's from or what features it's got, but I believe that they, you know, they generally have the capability to do those sorts of things. So here we have a weird-ass automotive connector used in the Hyundai cars. I've taken the two screws off the end. I had to actually prise that out. Had to get my knife in there and prise it out, but it does just pop off. And ta-da, we're in. We immediately see two surface mount electrolytic caps, which is a bit of a surprise. I'll talk about that. And it looks like we have some more screws in there. A vertical riser board for the camera, which of course you can see down in there. And it really is a beautiful case. And it looks like it sort of looks and feels, because of the lightness of it, it looks like one of these lightweight magnesium alloy type cases. It's really lightweight. It doesn't weigh much at all. Get in there and we'll rip these two screws out. Yep, screwdriver just makes it, thankfully. So I expect to see, as I said, some serious horsepower processing in here, and probably a dedicated chip for it. I don't think we'd find like an FPGA or anything like that. There's bound to be a CAN controller as well, because this will be CAN bus interface as well. I'm not sure what sort of you know, output signals they get from this thing, whether or not it's capable of outputting the video from the camera that goes to potentially a screen in the car. I don't know. No idea, but let's... Yep, we're out. Ta-da! And there we go. Oh, look at that. Mobileye STME IQ2. And, yeah, looks like we have another processor on the bottom there. Freescale, is it? Woohoo! Let's have a look. Yeah, so there you go. It's a company called Mobileye, or that's the brand STME. It's, you know, ST Micro, obviously. Do it, but I guess that's their technology, Mobileye. Maybe they've teamed up with someone. I'm going to have to Google it. I don't know. We've got some memory surrounding that, some miscellaneous, probably some power supply stuff, not much else. And the camera, of course, is on a little riser board there. Can I just whip that out? That is, yeah, that's just going to pull out. There we go. Not a problem whatsoever. Isn't that neat? I don't, you know, I'm sure they've done their, you know, shock and vibration performance tests on these things. Very extensive, they would be, on all this automotive stuff. Rev C, gone through a couple of revs, multi-layer board there. It'd be top quality gold plating on that. You can bet your bottom dollar. No idea what resolution camera. Now, one thing I potentially didn't expect to see in here, as I mentioned, these surface mount electrolytic caps here, they might be a polymer type one, which have a much longer life, but the reason I didn't expect them is because, as I said, that life expectancy thing. You know, automotive, it's operating at a high temperature, and of course the life of electrolytic capacitors goes down drastically with temperature. In fact, it's pretty much mostly dependent on their operating temperature. So it's a really big deal. So in a car, in a hot environment, already from the body, let alone plus the ambient temperature as well, they'd be, you know, 105 degrees C rated caps at least. And we'll have to look at we'll have to try and Google the type. They're a VCA, I assume that's the model number, so, or the, you know, the model type. Probably a top quality brand. They won't be a one hung low one. They'll be a Panasonic or something like that, no doubt. And well, that was too easy, folks. I googled VZA capacitor and bang, I popped up with a Panasonic datasheet. They are the ZA series, type V. We'll go into what type V is, but yeah, no surprises that they're Panasonic. Panasonic are, you know, one of the top, if not the top capacitor manufacturer in the world, always have been. So, and they are a conductive polymer hybrid aluminium electrolytic capacitor. So they are going to have a much higher life than your regular ones. In fact, the endurance, here we go, 10,000 hours at 105 degrees C. Low ESR, high ripple current, not a problem. They go up to 80 volts, and they're equivalent to conductive polymer type aluminium electrolytic, and there is a little characteristics change by temperature and frequency. Ooh, quite stable. I like it. But yeah, they're much better than, because they combine like a polymer construction, which means the electrolyte doesn't wear out as quickly. They still have it, but it doesn't wear out as quickly at high temperatures as you would in a regular aluminium electrolytic capacitor. We've got more stuff in the endurance down here. The capacitor shall be subjected to application of a DC voltage with full rated ripple current at 105 degrees C for 10,000 hours after stabilizing at room temperature. The capacitor shall not exceed the following limits. Thou shall not exceed. So yeah, after 10,000 hours at 105 degrees C at rated voltage and rated ripple current, they're still doing pretty darn good after the endurance. We're still talking, what size have we got here? Maybe a C size. We're still talking, you know, 2 ohms ESR at 100 kilohertz. So pretty darn good. I like it. And if we have a look at the marking information here, yeah, it's the first letter is the voltage mark, so V is 35 volts, so it's 35 volt rated cap, ZA series, Panasonic. They've done well. They've chosen exactly the right type, and 10,000 hours shouldn't be an issue. Because with 10,000 hours, you do some simple calcs. Even if you're driving the thing solid and it's at, you know, cars at temperature, and this thing's at temperature, but it's probably got, you know, airflow going through this thing anyway. It's probably not that hot because it's right out, you know, in the front bumper or something like that. So it's probably not operating anywhere near sort of engine compartment temperature, because it is a lane guidance thing, so it needs to poke out the front of the car. So it's not only would it get the cooling, unless you're going backwards, I guess, then it'd be getting probably, you know, at least some sort of a cooling effect in the front bumper part of the car, or something like that, I assumed. I don't know how they mount these things in the Hyundai cars at all, or where they're actually located, but you know, it has to be somewhere like that. So really, you know, 10,000 hours, but even if it was operating at a full 105 degrees Celsius, we'd still be talking, you know, 3.5 years or something like that at 8 hours a day, solid temperature like that. But even then, it's still, you know, it doesn't just suddenly die at 10,000 hours. These things, you know, still meet these specs at 10,000 hours. So it's still going to continue to operate well beyond that, because you would have designed that in. There's our little camera board. We should be able to take the screws off there and get to the bottom of the camera, but it won't be that interesting. Of course, a couple of fiducials on the board there for component location. Rev C board, and let's have a look at the front of the module. Once again, it looks like it uses that same magnesium alloy. So yeah, let's see what's under that. They've got like a plastic No, that's rubber. There you go. They've got a rubber mounting base on that. Let's whip that off. And ta-da, there folks is our sensor chip. That'd be a little BGA package, and that would, I presumably, maybe have some processing on the integrated in that. And there you go, you can see the BGA balls under there, stuck right down. And by the way, they did add some Loctite onto those screws, so of course they're serious about vibration in this thing. And just what is that gunk stuck to my ESD mat? I don't know, torn down too many things. And this, folks, is where all the magic happens. This ST Mobileye STME IQ2, and we're going to have to go for Google on this one, folks. Could be interesting reading, although I suspect we won't be able to get the full data sheet on this, just, you know, basic top-level marketing wank for it, really. You know, it'll tell you what processor it uses and all the features and all that sort of stuff, but yeah, really detailed data sheets, probably NDA, non-disclosure agreement. And on the back of that BGA device, of course, they got some serious decoupling happening there. Hey, that's a lot of caps. And the other processor on the bottom here is a Freescale SPC 5604. And well, I think we're going to have to go to the videotape for that one, folks. And it looks like we have a 10-layer board here, folks, because PCB designers, of course, like to put on these layer markers here on each particular layer. So there's number 10 there. You can see number 9 on the layer underneath, and then if you were able to see through the board, you go 8, 7, 6, 5, 4, 3, 2, 1 right on the bottom. Yes, there we go. Number 1, number 2. So they got the numbers all the way through there. 10-layer board. Why do you need a 10-layer board? Well, you've got to route out this huge BGA package here. Of course, I have no idea how many pins this sucker is, but there's all the bypass capacitor for the core. But yeah, look, they've got vias all the way in there, which is right to the outer edge of the chip. So it looks like they've at least got all pins going around there on the back of the BGA, like on the bottom of the BGA, at least going around there. They've probably got some center stuff as well, perhaps. So not sure what how many pins total, but to route out stuff like that, you know, it forces you into like a, you know, at least a 6 or 8 layer board. I would have guessed, you know, it'd be 8. Maybe, but yeah, they've just gone for 10 because, well, they're, you know, put in a ground layer between everything. So belt and braces. And of course, I haven't skimped on the connector. Genuine AMP. They don't get much better than AMP, and AMP will certainly charge you for the privilege. That's why cars are so expensive. And we got something that was they couldn't be bothered to populate down there. Not sure what. Let's have a look at that. By the way, it is a Rev D board, so they've had a few sucks of the proverbial sav there. And it looks like we've just got a couple of switching regulators around the place and stuff like that. Nothing too fancy. That's probably a low dropout linear reg for one of the cores. I'm not sure if it's got multiple voltage requirements or whatever on these chips, but no, I think this was a single 3.3 volt, wasn't it? There's the oscillator module, 10 megahertz. There we go. And yeah, there's not much else on here really, just miscellaneous support stuff. You see, like, you do a basic Google search on that and you come up with zip. I mean, you know, you could, if you spend a bit more time at it, you could decode these things, but I don't think they're worth it. Another switching converter on top, dead giveaway. There's your inductor, there's your high value caps. Nothing special at all. Got ourselves some micron memory there. And we've got ST. Of course, ST have got another design win. Well, no surprises whatsoever. There we go. We've got some flash, I believe. Yeah, that's actually a 64 megbit 3 volt flash memory. So, you know, even though it's ST branded on there, it's actually associated with Micron and Mnemonics as well. So, I don't know. One big incestuous industry. Not sure what that device there is. Either I Google it and I came and the first thing was a phase controller SCR. I don't think so. But interestingly, on the bottom of it, we have... Look at this. That's what is that? We've got two large precision resistors there, by the looks of it, and what looks like some sort of maybe common mode choke or something like that. Here we go. This Freescale microcontroller, the SPC5604, is actually the MPC5604. So I don't know why it has SPC on there, but this is all I can find. And I'm pretty sure it is actually the one. So here you go. What is it? It's a Corvair processor. A Corvair, like it's not an ARM or anything. It's a Corvair. Microcontroller is a gateway system designed to move data from different sources via Ethernet to receiving systems and vice versa. Woohoo! The supported data sources are, video data, audio data, radar data, other serial comms including FlexCAN, LinFlex, and DSPI. And here we go, features and specifications. It's got a 64 MHz Corvair E200 Zen-OH core. Geez, can you get any more obscure than this thing? I'm sure it's well known in the automotive world, but geez, I don't know. I thought the whole world was going ARM. Apparently not. 512K program flash, 4x16K data flash. Ooh, it's got 4-segment data flash segments in it. 96K of SRAM, that's quite a bit. One motion JPEG video encoder with image sensor interface supporting up to 1.2 megapixels. Wonder if that's used or not. I would have assumed that the main processor, which we'll take a look at, the main Vision Eye thing that we saw before, would have been doing everything. Mobileye, that would have been doing the whole shebang here, and this would have just been the interface. But anyway, it does have a video encoder interface. It's got Ethernet, and well, I don't think they're using Ethernet here, but they're using CAN bus, of course, some sort of flex CAN. And what else have we got? It runs off a single 3.3 volt supply, 64 pin LQFP package. That's what we saw. So let's go to the data sheet. And here's the data sheet, folks. We've got it. Look at this, Safe Assure by Freescale. That's I'm assuming, we'll have to check that out. I have to Google that one. I'm assuming that that's some sort of standards compliance system that if it meets that, it's designated safe silicon and all this sort of stuff designed for reliable applications. Something like that. We'll check it out. Up to 64 megahertz, single issue, 32-bit CPU. That's the type of core, the E200 ZOH. Compliant with power architecture embedded, variable length encoding. Blah, 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 fail-safe operation, programmable watchdog, non-maskable interrupts, fault collection unit as well, so it collects fault codes or something, presumably a Nexus L2 interface. It's got DMA, it's got general purpose E timers, 16-bit resolution, LinFlex, for DSPI channels, automatic chip select. Oh man, tons of stuff. This is definitely not your regular microcontroller, that's for sure. One safety port based on FlexCAN 32 message objects. FlexRay modules. It's got ADCs built in, of course. 2 of them, 10 bits, with 15 input channels. So, doing the regular microcontroller thing and just banging in, a dozen plus input channels on their ADC there. Programmable cross-triggering unit. It's got URs, clock generation. It's got an internal RC oscillator. I think I saw an external oscillator module on the board there, though. But, apart from... ballast resistor. On-chip single supply with external ballast resistor. And there you go. If you want to go read the details of this rather obscure processor, go for your life. There's the their E200 Z0 core. Woohoo! Nexus 2. Must be doing something magic. And yep, here we go, the Freescale Safe Assure functional safety program. As industry standards such as IEC 61508 and ISO 26262 require more sophisticated functional safety concepts, real-time control of safety-critical applications increases in complexity. The Freescale Safe Assure functionality safety program is designed to help you simplify the process of achieving system compliance with functional safety standards in the automotive and industrial markets. And that, folks, is why they've chosen this, because these things have to pass safety and compliance standards, and if you use one of these chips, which has been through this Safe Assure program or whatever, then your paperwork and stuff is probably much less, and your chances of passing these standards much higher. So if you're a design engineer working on these sort of things, well, you're not going to go use your little microchip part that you've been using at some other company. No, because you'd end up probably failing the safety and standards compliance. So you're going to use a chip, or you're probably forced into using by company standards, a chip that has all this safety and support automotive functional standards and compliance stuff. I don't know. If you want to read more about it, I don't know whether or not it's like silicon or whether it includes the compilers and the tool sets and other stuff. No idea. Go read it if that floats your boat. And here, folks, is where all the goodness happens. Mobileye. Yes, they are a company, but they've teamed up with ST, of course, who we saw branded on the chip there. And this is the STME IQ2. Well, it's just got IQ here, but this is the IQ2, and I believe they're working on the IQ3 at the moment, or I don't know, it might already be out. Not sure, but anyway, this is specifically designed for the task. Look at this. Oh man, you can go read all about it. Utilizing CMOS 90 nanometer process operating at 332 megahertz. Since their second generation processor for use in vision-based driver assistance systems, and is approximately 6 times more powerful than the predecessor, the IQ. The IQ2 follows the same concept, albeit more powerful, to that of the IQ. Dual CPU cores run in parallel with multiple additional dedicated and programmable cores. This allows even a greater range of multifunction benefits. Woohoo! Winner of the 2008 Best Automotive Design Award. There you go. It's quite old. Who knew? Unless you're in this sort of automotive market, you just wouldn't keep tabs on these sorts of things. So what's inside this little puppy? Well, it consists of 2 floating-point hyper-thread 32-bit RISC cores. They're MIPS 32, actually. There you go. They're not ARMs. They're MIPS 32K cores. 5 vision computing engines. Brilliant. I guess you need, 5 to do 5 different objects. I assume they dedicate a vision computing engine to each individual item that they're trying to track, either obstacles or whether they're trying to track the lanes. I mean, this is supposed to be a lane guidance camera, but maybe it actually does more than this, or at least the chip is capable of doing more anyway. Whether or not they've actually implemented, I don't know. So maybe they need 1 vision computing core per lane marker. If you're driving along the road in the center of the lane, then maybe they need a separate vision core for each white marker on the road or something. 3 vector microcode processors. Oh, sounds important. Denali 64-bit mobile DDR controller. 128-bit internal Sonics interconnect, whatever that is. Dual 16-bit video input and 18-bit video output controllers. So there you go. We can get video out from this thing. 16-channel DMA, several peripherals, MIPS 32K, CPU managers, 5 VCEs, blah, 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 blah. Very impressive. Oh, man, that's a lot of silicon. Wow, this sounds very impressive, folks. Look at this: classifier engines, image scaling and pre-processing units, pattern classifier units, tracker engine, image warping and motion analysis units. Ah, man, unbelievable. Well, there you go. It supports up all. So there you go. The interconnect ports can support up to 428-bit OCP buses. Woohoo! Huge. Supports a wide range of image formats: monochrome, Bayer, RGB, and input frame size up to 2x2 megapixels. Awesome. 4 data channels, blurring, subsampling, G-curve approximation per channel, programmable cropping frame size, up to 4 histograms per channel, and video output as well. It does output frame size 4096 by 2048. Very impressive. There you go. By using an audible warning upon an unintentional deviation from the driving lane, these lane departure warning systems create an intelligent rumble strip imitation that alerts the driver even when there are no physical strips on the shoulder of the road. So, you know, if you're going off, they have those rumble strips. Very common to have those on the road so that you go like that as you sort of, you know, you get that rumble sound and vibration as you move off the lane. But they're designed to do this by real-time visual camera ID, identifying the lane to make sure you don't drift off. Oh, man. So there you have it. That's very impressive. And no, I can't find a data sheet on quick glance. As I said, you probably need an NDA to get the full data sheet on this sucker. But by all means, all the links for these will be in the video description below. So click on them if you're interested in checking out all this stuff. Well, there's not much more I can tell you about that one, folks, really, but it's rather interesting. So thank you very much, Joey, for sending this in, and we'll no doubt do the airbag controller as well in another Teardown Tuesday, and could be actually interesting to try and power this thing up. If anyone's got any data on the pinouts here and the functionality of the pins, please leave it in the comments or on the forums. So that was certainly worth a look. And if you do have any more info on exactly what model, you know, what functionality this model has in this particular Hyundai car, then also leave it in the comments as well. So that was well worth a look. So if you like the mailbag segment, please give it a big thumbs up. And if you want to discuss it, the best place to do it is the EEVblog forum. Catch you next time.